So good evening, everyone, and this is lecture number 10, and we are dealing with in today's class we will deal with the lens makers formula, and today's class is going to be a very important one because we'll be covering a lot of those things which might just come as straight away straightforward questions in your exam. So whatever points I'm going to give you, remember them, note them. You might not find them in the module that you have or in the notes or in any books that you have, because whatever I'm going to tell you is from my experience and the previous questions that have come in the examination hall, and I expect that similar question will come, and you can if you know them, you can straight away tick them. As I told you, out of the 45 questions that you are supposed to get for solve 45 questions, no? Out of 50 you are supposed to solve 45, isn't it?
Yes, sir.
So out of those 45, what I assume is around 30 to 35 questions. Um, Around 30 to 35 questions are simple. Now, in that 30 to 35%, 30 to 35 questions that are simple, 10 to 15, or maybe even 20 questions could be straight away taking one. That you tick, you tick, you tick, you tick. And these questions are just based on whether you know the topic or not. So please note everything that we do. You may take time, not a problem, but note it down. Let us have a quick recap of what we had done in the previous class. In the previous class, we had seen the sign convention for lenses. This is not given in any book, so just note it down. I hope you understand it because we'll be using it. Sign convention for lenses had been done, and we were doing ray diagrams for convex lenses, and we had seen the 6 positions in which image is formed. Today we will quickly cover those position for the concave lenses, and you must have now understood that whatever we had done for concave mirrors, remember concave mirrors were converging mirrors. The same thing we have done for convex lenses, which are converging lenses. Do we recollect it? Both
Yes,
of them
sir.
together? Okay. So similarly, whatever we had done for convex mirror, the same thing will come for concave lens. For convex mirror, diverging mirror, power is negative. For convex mirror, we had done only 2 positions. Yes or no? Similarly, for concave lens, sometimes I just say something else in haste. For concave lens, we only have 2 positions. And what will be those 2 positions? Tell me, fatafat. The first position for concave lens would be,
Object at infinity.
the first position for concave lens would be object at infinity. And where will the image be formed? What type of image would be this?
At focus.
At focus. Will it be a real image or a virtual image? It is definitely a virtual image. It is highly diminished. Do we understand this? The same thing. Same thing. Exactly same thing. In bracket, I can also write it for convex mirror. Do we understand what I'm saying? The only difference here is, remember, 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 for a lens, a real image is formed. If the object is here, real image will always be on the other side. But for a mirror, the real image is on the same side. Do we understand this? That is the only difference. For a
Yes, sir.
mirror, this is a mirror, real image is on the same side as the object. For a lens, real image is on the opposite side. Do we understand this? Boys, do we understand this? Huh?
Yes, sir.
So this is the case. This is a virtual image, and this virtual image is very, very less than 1. That means it is highly diminished. Remember this, it is highly diminished. This is case number 1 when the object is at infinity. What would be case number 2, my dear friends? What would be case number 2, my dear friends? Tell me. Fatafat.
Object placed in front of lens.
Object placed anywhere else. Anywhere else you place the object. Whether you place it on the left hand side, whether you place it on the right hand side, doesn't matter. Do we understand, bacha? Whether you
Yes,
place
sir.
it on the left hand side or you place it on the right hand side, it doesn't matter. The image is formed like this. When the object is at any other place, the image is between F and optical center. It is virtual, it is erected, and it is diminished. Do we understand this? The same thing can be said for a convex mirror. The only difference is there the image is virtual also, but it is on the other side, virtual side. Everyone understands this? Yes or no? I'll give you 1 minute to note this down.
Done, sir.
Wait, sir.
Shall we move ahead in life? Life has to move on.
Yes, sir.
Boys? Ma?
Sir, wait, sir.
Wait, sir. So slow, sir. Right, sir. Let me know, sir.
వాళ్ళు దొంగలు బుక్కులు దొంగతనంగా రాసుకుంటారు ఏం కాదు బుక్కులు తీసుకొని రాసుకొని కథలు పడతారు. Completed, sir.
Okay, sir. Then what we are going to write is some important points. These points can come as questions in your exam. The first important point is like this. Number 1, a convex lens. Now, whatever I am writing for convex lens can also be written for.
Concave mirror.
So I write it as concave mirror in the bracket so that we are memorizing everything that we know. A convex lens or a concave mirror can form real as well as virtual images for real objects. Do we understand this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
For real objects, my dear friend, a convex lens or a concave mirror, it can form both real as well as virtual images. Get this?
Yes, sir.
Now, remember, I'm just going to note it down here. If the image is real, it can have magnification greater than 1. It can have magnification equal to 1. It can also have magnification less than 1. When the object is beyond 2f or beyond the center of curvature, the magnification is less than 1. Do we understand this? If the
Yes,
object
sir.
is at the center of curvature or 2f in case of a lens, the magnification is 1. If the object is between f and 2f, the magnification is greater than 1. We understand this, yes or no?
Yes, sir.
But for virtual image, the magnification is always greater than 1. Do we understand this? And virtual image are only formed when the object is between O and F. Do we understand this? And they
Yes,
are
sir.
always magnified. So if you have a lens which forms virtual magnified image, it has to be which lens? For real objects, if a lens makes virtual magnified images, which type of lens it is? It has to be a convex lens. Do we understand this, or this has gone above or it's saying bye bye, bye bye, I'm going? Yes or no? We understand this?
Yes, sir.
A convex lens, whatever I'm writing for lens, it is also valid for concave mirror. I will not write it. A convex lens can only form real images for virtual objects. Now, how will you get virtual objects? Don't worry, I'll give you an example of a question. You will be able to understand. If the object is virtual, then the image will be real. Do we understand this?
Yes, sir.
One thing convex lens cannot do. What it cannot do?
Convex lens cannot form virtual images for virtual objects.
Correct. A convex lens cannot form virtual eye image for virtual object. Remember this. Don't forget this. Virtual images for virtual objects, it cannot do. I hope everyone is writing.
Yes, sir.
Yes, sir.
A concave lens. Now, whatever I'm writing for concave lens is also valid for
Convex mirror.
convex mirror. Can form real and virtual images for virtual objects. For virtual objects, it can form real as well as virtual image. Now, how do you get virtual objects? You only get virtual objects when something happens, when there is a combination of two. We will do a question in which you will be able to understand how this virtual object comes. What next? For real objects, a concave lens for real objects can only form
Virtual images.
Virtual images. For real objects, the images are always virtual and they are always and the images are diminished. Do we understand this?
Yes, sir.
So if you get a question that for a real object, I am getting a virtual image and the image is diminished, what type of object, what type of lens it is or mirror it is? It is either a concave lens or a convex mirror. Do we understand this? One thing it
Yes, sir.
cannot do, what?
Concave lens cannot form real images for real object.
Very correct. Real images for real objects, it cannot get you real images. Who can do that? A convex lens can do that. Do we understand this, or this has gone above and saying bye bye, bye bye, bye bye, I'm going. Don't worry about me. I'll give you 2 minutes to note it down.
Done, sir.
What about the boys, sir? Done, sir, or not, sir?
Completed, sir.
Completed, sir. Okay. That takes us to the next heading. That was the main heading for today's class. Most of the question in this chapter are expected from this, and this is known as lens maker's formula. It's known as lens maker's formula. Any idea what this lens maker formula is all about? Yes. Anyone knows what is this lens maker formula? No? Well, you're not studied it before? Lens maker's formula, as the name suggests, this is used to make lenses because it's lens maker's formula. Now, what is a lens maker's formula? If I have a lens, now whatever type of lens I have, I'm just showing it to you in terms of a convex lens. It could be a concave lens as well. Doesn't matter as long as it is a lens, whether it is plain lens or not lens. One side, it's one thing would be curved. So we have this lens, let us say. Okay, this is the optical axis. Do we understand this? This is the principal axis. This is the optical center. Let me not call it O because O is object. So let me call it as C, optical center. Okay. Now, if the object is placed here, we call this surface as the first surface, yes or no? Because this is the surface from which refraction is going to take place for the first time. And this becomes your second surface, yes or no? If the object is placed on the other side, because it can happen, then the second surface becomes your first surface and the first surface becomes your second. Do you understand this? This first surface has a radius of curvature R1 and the second surface has a radius of curvature R2. And this is made up of glass of refractive index mu. An outside thing is air. Air on both sides. Do we understand the scenario? Then we can find the focal length of this lens. We are not going to get into the derivation. The focal length of this lens 1 by FA. What does this FA stand for? Focal length in air. mu. This is the LA. Why I'm writing it as LA? Mu LA means refractive index of the lens with respect to air. -1 1 by R1 minus 1 by R2. R1 is the first surface, R2 is the second surface. Do we understand this?
Yes, sir.
Okay. Now the point that you must remember here, important point, is that focal length F, it depends on the medium surrounding the lens. It depends on the medium surrounding the lens. F does not depend on position of object. What do I mean by this? You might think that, sir, I mean, if the object is placed on this side, the first surface become the first surface and second surface become the second surface. But if I move the object to this side, O dash, then this surface will become the first surface and this surface will become the second surface. In this case, will the focal length come different? No, the focal length never becomes different just because object is placed here or the other side. Focal length, no matter where you place the object and no matter wherever you apply this formula, we always get the same focal length. Convex lens remains a convex lens with the same focal length. Concave lens remains a concave lens with the same focal length. It does not depend on where you have placed the object or from where the light is coming. Do we understand this?
Yes, sir.
But it depends on,
Medium.
because here you have refractive index of mu with respect to L. That is the formula for focal length in air. So that means we will have a different formula for focal length in a different medium. Yes or no?
Yes, sir.
So what will be the formula for focal length in any medium? Yes, can you guess it? What will be the formula for focal length in a medium? Focal length in the medium, in any medium. Yes, what will be the formula? What would change? If you could just apply a bit of common sense, you'll understand what would change. Yes. No? Shall I help you? Here it will become mu of L with respect to M minus 1. This thing remains same, 1 by R1 minus 1 by R2. Now, as soon as you write this thing, remember what is the value of this thing? This thing is equal to mu of length with respect to air divided by mu of medium with respect to air. Do we understand this? Yes or no? No, yes. Raise hands
Yes,
will
sir.
give me more confidence. So this is how you can understand. Since mu comes, as soon as mu comes, you will have the focal length changing. In fact, a concave lens can also become a convex lens, and a convex lens also can become a concave lens. We will show it to you. Don't worry, I'll give you 2 minutes. Note this down. We're writing everything that can come in the exam in the form of points. Remember these points. Any one of these points will be in the paper. I can assure you that. 2 minutes.
ఆగు జర మెల్లగా రాయి ఆగు.
Completed,
Ranjit
sir.
Bacha, done?
Yes, sir.
Okay. Now, next point, every point is an important point. I can write the formula for focal length in the medium divided by focal length in air. What will be the formula? It will be focal. Oh, you can put the formula and get the answer. It will be mu of length with respect to air minus 1 divided by mu of length with respect to medium minus 1. Do we get this? Yes or no? If a lens is put in any other medium, suppose the lens is in air and you put it any other in any other medium, will its focal length increase? Will its focal length decrease? Will it remain same? Or you don't know? It can increase or decrease. I don't know. Compared to air, that is I'm saying. If you have a lens in air, you can measure its focal length. If I dip it in any other medium, will the focal length increase or will the focal length decrease? Will the focal length increase? Or will the focal length decrease?
Increase, sir.
Focal length in the medium will be more than focal length in air. Do we understand this? Because mu of length with respect to air will always be more than mu of length with respect to the medium. So the ratio will be greater than 1. The focal length will increase. Do we understand this? Focal length increases. This also implies that the power of the lens will decrease. So they can ask you this question in terms of focal length of the lens increasing or decreasing. They can ask you in terms of power of the lens increasing or decreasing. Do we understand this or this has gone above our head saying bye bye, bye bye, bye bye. I'm going.
Understood, sir.
Okay. Note it down, please.
Done, sir.
Boys, done?
Not it.
Okay. I'll give you 2 minutes to do it.
Completed, sir.
Completed, sir?
Yes, sir.
Okay, sir. Then comes this. As I told you that inside a medium, the nature of the lens can change. In general cases, when you have a lens in air, the refractive index of lens is always greater than air. So a convex lens is a convex lens A concave lens is a concave lens. Nothing changes. But if you dip it in a medium whose refractive index is more than the refractive index of the lens, then opposite thing will happen. A lens which is convex in air will become concave. If I dip it in a medium which has got more refractive index compared to the lens. Do we understand this?
Yes, sir.
If I put it in a medium which has the same refractive index, I put glass in the same thing from where I created it, will it behave like a lens? No, it does not behave like a lens. Light just passes through it. Do we understand this?
Yes, sir.
Yes, sir.
Okay. Please note it down. And then we'll move on to some questions. Have we done this? You don't have to draw everything, beta. You can just write
Done,
it.
sir.
Just understand. Do you understand it? Bacha?
Yes, sir.
Okay. Then we can move on and solve a simple question. This question is, I think, taken from your module. Question number 27 from your module, I think. You can have a look at it and you can solve this question quickly. Find the focal length of a double convex lens. So it is convex on both sides. First radius of curvature is 15. Second radius of curvature is given with sign minus 25. Not normally given with sign. You will normally get a diagram, but just this is the first question. Therefore, it is given with sign also. The refractive index of the lens material. Normally, the refractive index of glass, wherever question comes, will be given as 3 by 2, 1.5. So I'll give you a minute to solve this.
Sir. Sir,
Yes, we got the answer. Everyone?
75 by 4.
75 by 4. I don't know. Let us see if I can get the same answer. Solution. So how I am going to do this? I'm going to put the formula 1 by FA will be equal to mu. I'm not writing LA. I understand it is mu. Mu minus 1. 1 by R1 minus 1 by R2. I will put the value. Remember 1 by FA. Mu is given as 3 by 2. It's always 3 by 2 minus 1. So it is always half. You can remember it that way. Into 1 by 15 minus 1 by minus 25. I think you can solve this, yes or no? Taking LCM and HCF and all those things.
Yes, sir.
What is the answer you are getting, bacha, from here?
75 by 4.
Sure.
Sir, F equals to 75 by 4. Actually, we will get 1 by F equals to 4 by 75.
Okay. Everyone is getting the same answer? Boys?
Yes, sir.
Well done then, sir. This is how the question should be. Ideally, but it is not like that because they will not give you the question with sign convention. They will give you a diagram. So I'm going to show you a diagram. I'm going to show you a diagram. And now I'm going to present the second question. It is again taken from your module only. And let us see if you can give me the answer for this one. If you want to see it from the module, I think it is question number 47 from your module. For me, it is question number 2. So this is how it is given. You can see that this is a biconvex lens, yes or no? In fact, an equiconvex lens because both the radius of curvature are same. You have to find the focal length of this lens. You have to find the focal length of this lens. Give you 1 minute to do it.
Sir,
Yes, bacha, what is the answer?
sir, is it 10?
It is 10. It is 10. Not is it? It is. Is it? Answer is it is. It is 10. Yes. Boys, did you get the same answer?
Yes, sir.
Now see, I'll give you a small, you can call it trick or whatever. See, this is a biconvex lens. Both the radius of curvature are same. Yes or no?
Yes, sir.
And the refractive index of glass is normally 3/2. Yes or no? Now, if I
Yes,
put
sir.
this in the formula, bacha, 1 by f in air, I'm not writing a, saving time. So this is 3/2 minus 1. If I place the object here, this will be R1, yes or no? And this will be R2, yes or no, bacha?
Yes, sir.
Both
Yes,
are
sir.
equal to R. Both are equal to R because same. So the first radius of curvature is positive 1 by R. Do we understand this? Minus the second radius of curvature is negative. Yes or no? Do we understand this, bacha? The first radius of curvature is positive. The second radius of curvature is negative. Do we understand this? I will
Yes,
need
sir.
raise
Yes, sir.
hands because if you don't understand this, a single mistake here, finish. Answer, finish. Do we understand this? Again,
Yes,
Yes,
sir.
sir.
so what will you get? The 3/2 minus 1 is half. And there you will get 2 by R. Half and half will cancel. And straight away your answer would be F is equal to R. So as soon as you see a equiconvex lens with radius same and refractive index 3/2, your answer will always be equal to R. Do we understand this?
Yes, sir.
Sir.
That is how you can save some time. Now, how do you get the shortcuts? You get the shortcuts if you do, let us say 20 questions, 15 questions on this. You will understand, okay, this is 10, it always comes R. You will understand, okay, as soon as I see this, I will just put R. This is what you call smart hard work. Remember, examination, NEET is not clear in the JEE, NEET is not clear in the examination hall. You are clearing NEET now with practice. Do we understand this? Yes or no? No, yes.
Yes,
Yes,
sir.
sir.
Then if you understand this, then this is a question coming up. Tell me what is the focal length of this again. Your brain can work faster than your hands because for your hands to work, first your eye sees it, then it sends signal to your brain, then your brain tells hands to do something, then your hands does something, then it again sends, then your eyes again sees it, then again the same process. What is the answer for this one? Yes, my dear friends.
Minus 10, sir.
Minus 10. As soon as you see both are same, refractive index is 3/2. It is a concave lens, so answer will be minus 10. Do we understand this, my dear friends? Yes,
Yes,
sir,
sir.
or no, sir?
Yes, sir.
I hope this is how you make so-called shortcuts. These are not shortcuts. These are things that you learn by practice, my dear friends. Yes or no? Yes or no?
Yes, sir.
Then comes a question which obviously you will have to solve because does not have that same radii of curvature. Anyways, you know how to solve it. This is the type of problem that you are supposed to face in the examination hall, my dear friends. This might be the same problem that you might get in the examination hall. Remember, NEET is not cleared in the examination hall. It is cleared right now in front of your eyes. This is the question. I've forgotten the question number. I'll call it question number 4. Find the focal length of the lens as shown in the figure. If light is coming from the left hand side, A. If light is coming from the right hand side, will the focal length change? Huh? Light coming from here, light coming from there. Does it change? Yes, sir, or no, sir? It does not change. And we will see it with our own eyes, with our own hands. We will see it. Seeing is believing. 2 minutes you have to solve it. Give me the answer. Stay happy.
F is equal to 16.
You got the answer, bacha?
F is equal to 16
F is equal to 60. Plus 60 or minus 60?
plus 16.
Does it change if I go from here to there? It will not change. If I place the object here, my dear friends, O, this becomes my R1 and this becomes my R2. Yes or no? Quickly, let me solve it for this end. I will not solve it for the other end. So I will write 1 by F will be equal to mu. Mu is given as 3 by 2. 3 by 2 minus 1 is half. So let me just write half. Yes or no? Do we understand this? The first radius of curvature is 20. Is 60. Is it plus 60 or is it minus 60? Plus 60 or minus
60.
Very good. Minus 60 minus 1 upon the second radius of curvature is also like concave. Plus 60 plus 20 or minus 20?
Minus 20.
Minus 20. You solve this and you end up with plus 60 centimeters. So this is a convex lens, and this type of lens is known as concavo-convex. Do we understand this, or this has gone above by saying bye bye? Bye bye. I'm going. Do we understand this, kids?
Yes, sir.
Pakka?
Yes, sir.
Okay, time has really run out for us. So let me see if I can find one more question for you, which I shall give as homework, or probably I'll ask you now. What is the answer for this one, my dear friends? I hope you will not disappoint me. What is the answer for this one? Tell me, bacha. Fatafat. Chatasat. Fatafat. Huh? There are two questions given to you. Question number 1 and question number 2. What is the answer for the first one? Forgotten. So I'll give you these two as homework. I hope you will be able to do this. We will go ahead with some more questions and some more points from this lens maker's formula and then move on to the lens formula in the next class, that is tomorrow. I hope you try a lot of questions based on this. You have the module. I've also sent you practice sheet. Yes or no? Try questions on that sheet. The more you practice, the better you are going to be. So I'll see you in the next class. Have you understood how to find out focal length of a lens by lens maker's formula? Yes or no?
Yes, sir.
Yes, sir.
Okay, then I'll see you in the next class. Take care. Have a nice day. God bless you all.